Alright guys, so in this video we're going to be looking at this topic called parallel lines and transversals. So let's get started. First, let's start off with this definition. Parallel lines, we know what parallel lines are. Parallel lines are lines that do not intersect, right? That's from the past few videos. Now we're going to be introducing this new thing called transversals. And a transversal is a line that cuts through two parallel lines, right? It cuts through two parallel lines, all right? So let's look at this example right here. Here we have line L, that's a cursive L, and line M. And line L and line M are parallel. A way to denote that would be to write like this. L is parallel to M. So whenever you want to say, or maybe you're reading a problem and you see this just means line L and line M are parallel, because the little symbol for parallel is just two parallel lines, all right? So we have line L and line M are parallel. But now let's see what the transversal is all about. So the definition says a transversal is a line that cuts through two parallel lines. So here we have the two parallel lines. Now let's draw a transversal which cuts through both of them. So we'll draw something like that, all right? And a transversal is a straight line, all right? So you might want to put the word straight here. A straight line. It's a straight line, right? So here we have our transversal. It cut through the parallel lines L and M, and maybe I'll call it transversal for now. But in the future, you might see it's labeled like maybe Q or P or O or something different. All right, but I'll call it the transversal so we know what we're talking about. So here's the transversal. It's this one right here. All right, and what's special about the transversal is if you can see what happened when we cut these parallel lines. If you kind of covered this part up, you can see that you have angles here, right? You have 1, 2, 3, 4 angles here, and you have another 4 angles here, 1, 2, 3, 4. And if you look a little closer, you can see in the last video, we talked about vertical angles being congruent and vertical angles in general. And as you can see here, this kind of looks like two straight lines intersecting. And this looks like two straight lines intersecting, right? So what's so special about the transversal and how it goes through parallel lines is that now you can number, you can number the angles, and interesting things come from the fact that we had this line cut across these two parallel lines. So for example, let's number these. 1, 2, 3, 4, 5, 6, 7, 8. All right, and let's just state some facts. Let's pause for a second and state some facts that we know from vertical angles. Right, so pretend we just have this part, right? As you can see, we have two straight lines, and what you can get from this is that we know vertical angles are congruent, right? Two straight lines intersecting, so vertical angles are congruent. The vertical angles here are 1 and 4 and 2 and 3. So what we can write is, we can write angle 1 is congruent to angle 4. We could also write angle 2 is congruent to angle 3. Angle 2 is congruent to angle 3, right? And that pretty much does it for this top part, right? We labeled the vertical angles. 1 and 4 are congruent, and angle 2 and 3 are congruent. But now we can go down to this bottom one down here. All right, so this one says 5, 6, 7, 8. Okay, so what we can do here is angle 5 is congruent to angle 8, right? Because 5 and 8 are vertical angles. If you kind of cover this up, you can see two straight lines intersecting. 5 and 8 are vertical angles. 6 and 7 are vertical angles. So 5 and 8 are congruent, and 6 and 7, angle 6, will be congruent to angle 7, right? So what we kind of did was we kind of just like broke this up. We pretty much just treated it just now as if it were two separate things, right? But now let's consider it as one whole picture. All right, so now let's see where the interesting stuff, how all this stuff comes into play. So what's going to happen here is we're going to have some new stuff come up. All right, and this new stuff is going to be called, we'll start off with corresponding angles. All right, so maybe I'll put it right here. Corresponding angles. And what corresponding angles are in the case of transversal and parallel lines, corresponding angles are just the angles in each one of these where it's located in the same spot. For example, angle 2 is like in the top right. You see how for example, if you were to tell someone, if you just had this and you told them where number 2 was, angle 2, you'd say it's in the top right. All right. And if you told someone where angle 6 was for this one, you'd say it's in the top right also for this one. So as you can see, angle 2 and angle 6 are as if they were in the same spot, the same location, just in a different position, right? And what's actually interesting about that is because we have a transversal going through this, and because these lines are parallel, angle 2 is actually congruent to angle 6. All right, so what we can write is angle 2 is congruent to angle 6. And not only is angle 2 congruent to angle 6, but angle 4, which is in the bottom right, is congruent to the one that's in the bottom right also. So we can say angle 4 is congruent to angle 8. And similarly, we can do the same thing with the 1. So if we look at the number 1, it's like in the top left of this one, right? It's in the top left. Well, it's actually the corresponding angle to 1 is angle 5 because it's in the top left of this one. So we can say angle 1 is congruent to angle 5. And we can say the same thing for number 3. All right? Angle 3. Because angle 3 is in the bottom left of this top part. Angle 7 is in the bottom left of this bottom one. So we can say angle 3 is congruent to angle 7. All right? And we can make a huge generalization here. And we're going to say that corresponding angles are congruent. All right, this is important. Okay, it's very useful to have that corresponding angles are congruent. All right, and as you can see here, I drew the sign for congruence. So remember that means congruent. And also, I also want to point out that corresponding angles are congruent. That's just like what we did. I used the word in the vertical angles video. And this is actually also a conjecture. So we assume it to be true. We assume this to be true. So this is actually called the corresponding angles conjecture. So we're not going to prove this, and it actually doesn't get proven. We just assume it to be true. All right. So we have that corresponding angles are congruent. So 1 and 5 are corresponding, congruent. 2 and 6 are corresponding, so they're congruent. Angle 4 and angle 8 are corresponding. Angle 3 and angle 7 are corresponding. And these corresponding angles, they come up immediately the second you make a transversal, the second you take two parallel lines and you make a line in between them, you get these corresponding angles. All right. Now, not only do you get these corresponding angles, but you also get another neat relationship between these angles, and that's that angle 3 and angle 6 are also corresponding. All right. I'm sorry. They're not corresponding. They're congruent. Angle 3 and angle 6. So what we can say here is angle 3 is congruent to angle 6. Okay. This one's also important because what this one allows us to do, angle 3 being congruent to angle 6, we call these alternate interior, because as you can see, we're alternating across the transversal and we're on the interior of these parallel lines. We're on the inside and we're alternating. And so we say angle 3 is congruent to angle 6, and we call those alternate interior angles. All right. And not only do we just call these alternate interior angles, but alternate interior angles are congruent. I'll put it in parentheses, are congruent. Also very useful. All right. So how many sets of alternate interior angles do we have here? Well, we have the angle 3 and angle 6 are alternate interior on the inside. And we also are going to have angle 4 and angle 5. So angle 4 is going to be congruent to angle 5. All right, for the same reason, alternate interior angles. Alternate interior angles are congruent. All right. So now that we have alternate interior angles being congruent and and corresponding angles being congruent, maybe we can state some facts about transversals and parallel and going through two parallel lines in general. All right, and what we can say here is we'll just make some generalizations, and we're gonna say that each pair of vertical angles here are congruent, right? 1 and 4 are vertical angles that are congruent. 2 and 3 are vertical angles that are congruent. 5 and 8 are vertical angles that are congruent. 6 and 7 are vertical angles that are congruent. So the first generalization we'll make is we'll say each pair, that says pair, P-A-I-R, of vertical angles are congruent. What else did we learn? What else did we learn in this video? We also learned that each pair of corresponding angles are congruent. 1 and 5 are congruent. 2 and 6 are congruent. 3 and 7 are congruent. 4 and 8 are congruent. So what we can say now is we can say each pair of corresponding angles are congruent. All right, corresponding, just think of them as in the same location. All right, so here's angle 1, here's angle 5. Angle 1, it's like in the top left. Angle 5 is like in the top left. So we say they're corresponding, and you do the same thing with the rest of them. All right, and then the last generalization I want to make, I'm going to put it over here. The last generalization I want to make is I want to say that each pair of alternate interior angles are congruent. All right, we have alternate interior angles. We have angle 3 and angle 6 are alternate interior, and then we have angle 4 and angle 5, right, from this one, are alternate interior. Okay, and they're congruent. All right, and we can also say, just for the record, it's not for we won't need it in pre-algebra, but not only are alternate interior angles congruent, but alternate exterior angles are also congruent. Alternate exterior. So now look at the like if we're on the outside of the parallel lines, the alternate exteriors are also congruent. So what we could add here is we could add angle 1 is congruent to angle 8, and angle 2, alternate exterior on the outside of the parallel lines, angle 2 is congruent to angle 7. Angle 2 is congruent to angle 7. And who knows, maybe that'll help you out on a problem. Right? So those are called alternate exterior angles. All right, who knows, maybe that'll help you out on a problem for the FSA or on the test. All right, so those are alternate exterior angles, 2 and 7, 1 and 8, because they're on the exterior, they're on the outside of the parallel lines. Alternate interior, alternate exterior. All right, and we're gonna stop here. Just for the record, in the upcoming videos, we're gonna be doing how we did in the last video when we started applying complementary, we started applying straight angles. We're going to be doing the same thing, and we were finding x and stuff. We're going to be doing the same thing with parallel lines and transversals. All right, so I'll see you guys in those next videos. Thanks for watching.